Let people join. So whoever has already joined. So how was it? Like anyone did any practice? I did not see anything happening on Discord actually, except for two, three people. Nobody tried anything. We can talk. You can unmute and talk right now. Any problem with the CMake thing and all?
Amit, I
Hello.
was not well last week, so I couldn't do it.
Okay. So this week, are you well now? Like you are okay? Good.
I'm getting better, so I'll pick
Okay.
from here this week. Yeah,
Okay. You are in where? You are in Norway or somewhere, right?
yeah, yeah, yeah. I live in Norway.
Oh, okay. So it must be pretty cool, right?
Uh, yeah. So here we look forward for sun. Like when we were in India, I was in India. We look forward for the clouds, but here it's the
Hmm.
other.
Yeah. What about Northern Lights?
Yeah, we have seen it. You have to go to far north of Norway
Hmm.
to see northern lights, somewhere around the Finland border.
Okay.
But sometimes you are lucky, then you can also see it in Oslo.
Good. Good. So you are in Oslo right now.
Yeah,
Okay. Okay. Great. So okay, get better. Hope you will start doing the projects and all.
yeah.
But did you get? But did you go to the recordings? Like, did you watch the recordings and all?
Actually, but not much. Means I have to do first day. Second day
Hmm.
I had joined last week.
Okay. 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 What about others? Anyone tried to do the project? Anything? The logger project we have done as we gave as a homework. Anyone tried to do it? Actually, it is a very good project if you can do it properly. If somebody would have tried, no, I would have told you what other things you can do with the logger. But I didn't see anyone trying.
Actually, I have implemented some basic functionalities,
Hmm.
created a shared library, and created two syncs for console and file, and just tested the working.
Hmm. So do you incorporate the config files where you can put all the where all I need to put my logs, whether to console or to a
No,
particular file? So
not
those
yet.
things you can do.
Yeah.
Yeah, right. Okay, I'll see what. So we can actually do that project properly. Like logging is a very good project to do. We can use this project in our upcoming whatever projects we'll do. Fine.
I think I was also asked this question of logging in one interview to write
Hmm.
because I think it is to handle the multi-threaded scenarios also.
Hmm. Yes, yes.
So it's a good interview question, right?
Yes. So actually, I wanted to take it like bit further. So once you have done this logging, like even if simple logging project, after studying multi-threading and all, we would have incorporated multi-threading scenarios in our logging also. Yeah. So
Hi, hi Amit. Actually,
hey,
I
hi, hi.
joined. I joined today actually, so
Yeah.
I could not had a chance to see about
Mm.
those logging and all. But I have seen your video. It has been
Mm.
very nice, and I could able to understand. But now I need to start. I have not yet actually
Yes,
started.
yes, great.
Yeah.
The more effort you guys also put in, like the things people like you guys also give a lot from your side, like code a bit, put it on Discord. I'll be more than happy to have a more, fruitful discussions. Otherwise,
Actually,
I will
I
just come and deliver what I have, what I already know. I'll just deliver it.
yeah. That's correct. That's correct. Actually, it has
Mm.
been yeah. Actually, it should be from more from us, and you can guide us something.
Yes,
That
yes.
is good. And
Because
I yeah. Sorry.
yeah, the kind of topics we'll be doing throughout this course, it will be very interesting. Like people, like you guys should be very interested about what topics we'll be doing. So if we are going to have good discussions, it will be very interesting.
Yeah. Actually, Amit, I have a one query regarding the like this logging library, whatever now you have mentioned.
Mm.
Unfortunately, I did not see about those things.
Mm.
And do you suggest with any design patterns? Usually, what I heard is singleton is one of the thing they
Yeah.
do. Is there any other thing do you suggest? And so maybe we can try with that also. That's what I'm thinking.
You can
If you
start
have
with the singleton. Singleton is good. Maybe you can go with some factory and all also. But you
uh,
can start with the singleton.
okay.
Okay, okay.
Amit, one quick thing. I am excited that this course about what you have
No,
written
your
that
voice,
we are going to
one
handle.
second, Just come again, come again. Your voice was little suppressed, I
Yeah,
think.
okay,
Yeah, tell
okay.
me.
So I am excited that you said that we are going to handle millions of connections. How to write applications doing millions of connections. Right. That is the
Hmm.
So that's quite exciting because that is something which I would like to learn. But before
Yes, yes.
this, we were doing it through was I'm not from web background much, but were we
Hmm.
doing it through IIS or Apache server and all, and we didn't have
Hmm.
to take care of these things?
See, those Apache servers and all are actually a code only, right? Somebody have written it,
Right,
right? So they would have taken care of it. You are just using that application to create servers. Now, in this course, what we'll be teaching will be creating those Apache servers, or think of it like this: we'll be creating those libraries or executables.
right. And now in the web development also, I don't see a lot of people using IIS or Apache, and they straight away use Node.js or something, and they implement their
Hmm.
own servers. So that is
Yes,
right.
yes, 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 yes. So we'll be creating our own servers,
Okay.
but not directly. So see, when you create the Node.js, when you use Node.js library and all, no, for creating a
React,
server,
yeah, React or
internally, yeah, internally they are using libuv library. Node.js is using libuv library, which is written in C++. And when you go and see those libraries, no, internally they are using those epoll and IOCP concepts and all to create those very high speed servers, high throughput servers. So those
and
things
we are going to
we are
cover it.
going to study,
Okay, great, great. Thanks.
right? So think of it like we'll be creating something similar to libuv libraries,
Hi, Amit.
right?
Yeah, I have one last, I mean, the workflow I just tried to implement. I'm in the middle of it. Uh, for the SPD logger, what I thought to do is I pulled the source code of SPD logger, I compiled it, binaries in the CMake. I pulled those config CMake files and library, static library I see in the SPD log, and placed in a folder called third party in my project.
Okay.
So I am trying to follow an approach which fits me more of CMake, like find package, to use find package and use the target name, the target
Library.
scope, exactly, target
Hmm.
scope library to
Hmm.
link it with my project. That is
Hmm.
design I thought, simple design I thought to
Hmm.
start on, do on my project.
Hmm.
Yeah, that's it.
Okay.
Yeah.
Yeah, you can if once you do now, you can put it on Discord that I have done this. I'll also get to know, and
Yeah.
maybe other people can also benefit from this. Okay, so let's start with today's class now. I think we have to do a lot of things in these 2 days, these two weekends. So I'm gonna start. And so last week I told that I'm just gonna very first I'm gonna show you how to like download and use your external libraries, use external libraries in your project. So quickly I'm gonna show you, and then we'll quickly move on to the other things, right? So I'm gonna share my screen. So let me know once you see the screen, right? Share. Can you guys see the screen? No, one second. One second, one second.
Oh, yeah, we were able to
No.
see your screen actually.
Huh. This one or this one? We are able to see VS Code or something else.
Not now. Now I think we can see you now, but briefly we saw
One
your
second.
screen.
Target lead library. Yeah, I think now you should be able to see it.
Yeah.
Yeah. Okay. So this was the thing which we were doing last weekend. This all where we left. And I told you some few commands that you can use in your CMake, and we'll keep using CMake in our other projects as we keep on going. So whatever you need to know, like mostly okay, how to like create the target and how to link the libraries and all, how to change the directories where the targets are built. I just want to show you one last thing, and I have given you a notes on the CMake that includes everything which I have said and which I have not said also, so that you can go through and refer to. So one thing I'm going to show you is, so suppose there is a library called so somebody was talking about SPD log, right? So this is a library, SPD log, which is used for logging in C++. It is very good library you can use. Sorry, SPD log GitHub. So if I go here, you can see this SPD log library, right? So how, if I want to use this in my project, how I'm going to use it? So what I can do is, everyone is now concentrated, right? Everyone is looking into the screen, and I'll keep reading a chat in between. Okay, so what we can do here is, so this was the CMake list that we are using for our projects. What I can do is, I can go here and use this include fetch content. So this is the thing we can use to directly download the library from, like, from the GitHub and all, and then directly use in our project. So what we can do is include fetch content, fetch content, give it some. So this is the thing which we'll use, fetch content. And what we can do is, fetch content requires fetch content declare. Let's see if it gives fetch content. Not this. This one. I'll just directly copy paste this. We can directly see it. So fetch content declare. The library name is SPD log. And what is the repository? GitHub. Like, you can directly see here. If I go here, and if you see here, SPD log.git. And if I want to see, so this is the one, this is the path, spdlog.git. You can give it here. Okay, this is the Git repository I'm trying to download. And this is the Git tag, means which version, like which branch and which tag you want to download. So suppose you can see here 39 tags are there, right? If you click here, there are different tags that you can download, different versions. So this is 1.4, 114.1, 114, that you can go and ahead and download. So that Git tag you can give here. So right now I'm doing 1.9.2, right? And after that, once you have declared this fetch content, what you can do is, you can directly make this, you can directly do this. Fetch content, make available SPD log, which is this one, this thing, SPD log that you can put here. So after this statement, it will start downloading and it will start setting the things library, what it has to do inside your project, right? And once you have done this, what you can do here is, how you will add this to your project is, you can directly do this. Target link library. So this we have already given. You can directly write this private label. Once and I will move this here. Yeah. So this SPD log is, this CMake will directly recognize this SPD log is directly, you are talking about the SPD log library, right? And I was trying with the MySQL. Okay, this is done. Shared library. Sorry, my static library. And you need the include directories, right? So if you can do this, so target include directory and this SPD log source there. So you will think where are all these things getting defined, right? SPD log source there, or maybe SPD logs, where are these things getting, how this CMake is getting to know ki what is the name of this and all, right? So the thing is ki this SPD log, this library only, no, whatever we are seeing here, this thing will have its own CMake, which will define these which will define these variables for you, so that you can use it in your libraries, in your project. So once if I go ahead and do it, so suppose I do CMake dot dot. Some error is coming. CMake list.txt minimum. That is okay. That is deprecation. Next 34. Okay, this is simple calculator. I have given my app. This one. Maybe I can give this here. Open this. Remove this.
On line 39 also, it's my app.
Yeah, correct. Simple calculator. So build is done. And if I go ahead and do a cmake dash dash build dot, so it should run. And if you go ahead and see here in build directory and inside, if you go inside dependencies, I think you can see that it has come with this spd log build and source and everything, right? Can you see here? I did means CMake did this all for you. Like after this, no, this fetch content make available. This downloaded your SPD log library here in dependencies. And then if you go inside this, I think there is CMake files, and there should be CMake install.cmake. There are some CMake files which will define those variables for you that you can use in your project directly, right? It's clear, right? Like nothing fancy or anything here. Like if you have to download something like this from the third party library, you can give this repository name tag, library name, and then you can use the predefined variables given by that library. First you do make available, and then you can use include directories. Sorry, this one target link. You link that library, and then you can use that target include directories. Yeah, so fetch will do this every time. I don't think does this every time. And so there is one more command that is available. That one second, I'll tell you. So there is something called include external project. So this is one more command that also does the same thing, but it has more fine grained control over which library, how you are downloading, how you are setting things up. So see, when we are doing fetch content, no, we didn't have much control over how where it is putting the library, where it is downloading, when it is downloading. But with this particular command, include external project and all, this external project at, it is similar. It will download, but you have more fine-grained control over how it is downloading, how where it is putting the library and all. That I have given in the CMake notes also, that you can go ahead and see it. Right? Correct? Now I think
So,
you can go ahead and
so
play
it
with it.
so it
Yeah, yeah, tell
downloads
me.
in the local repository, and then if it is not found, only then it goes to the net and get it.
First, it will see it is already downloaded or not.
Okay, in the
It will
dependencies. Okay,
intent dependency. So that's what
okay,
I'm saying. See, this fetch wala has less control, like user has less control over how it is downloading and what variables are getting set, where it is getting downloaded. If you want more control, how you are downloading and all, you can use this external project add. So this
okay.
gives you more fine-grained control. And I've given the whole thing in the notes also, how you can use external project. Okay. So with this, I think I'm going ahead and closing this CMake wala part for now. Like we'll if something comes up that we'll have to use some other commands and all, we can directly tell at that time. But now you will not have problems with this CMake if any new commands also comes, right? Like you understand the logic, how it works. Only thing you need to do something, you just need to find on internet what command I can use for this in CMake, right? Is it fine that we can close the CMake for now and go ahead with other topics? Right now, a lot of things we have done for the build. Right now, let's write some actual code. Okay, so even if you have some problems with the sim, see the thing I told you, ki, until you unless you try, you won't find any difficulties. If you start finding difficulties once you are trying only. So once you try, you put it on Discord that see I am doing this, but I am getting this problem. Then again, we can have a discussion how to do that in CMake, what all commands that you can use. But at least try to do. At least you use that logger project to build that logger project, create shared library and all, right? So that you can use the CMake thing, right? So going ahead, okay. So in this week, like today and tomorrow, I'll set the context that what we'll be doing. So first we'll be doing is so if you have seen the curriculum, no, there was a topic called STL that we were doing in, I think, in the fourth week. And then today, in this week, we were supposed to do multi-threading and some async library, async API, something, right? So what I have decided is there is no point of doing HTL at that time, like because we'll be using a lot of HTL features and HTL containers and algorithms. So we'll be doing the HTL first, then we'll go ahead and do the multi-threading part, which will be this week's topics, like HTL and multi-threading. From next week, we might be doing multi-threading a little bit again on the next week, and then we'll be starting with the socket concepts. So next we'll be doing socket. We'll start with the socket and networking. Is it fine with everyone? Because doing STL at that point of time, when we have already used a lot of its features, doesn't make sense, right? So that I have tweaked a little bit. So we'll be starting with the STL and I will not spend so much time on STL. I will be giving you some code. You can directly tell me, okay, this happens, this happens. I'm assuming a lot of you must be knowing a lot about STL. You must have used STL, right? Anyone here who doesn't know about STL, like what is STL? Anyone here? Standard template library.
Yeah, I have also done STL, but if you can cover somewhat tricky questions in STL,
Yeah,
which is
yeah, that
typically
I'll cover. That
remove,
I,
erase, idiom, and all those things,
hmm,
right?
hmm,
So
hmm, hmm.
it will be one more revision for us.
Yes, yes, that I'll cover. So some tricky part that we commonly use that we have to use in our projects also, and commonly used in any other like third-party libraries also that we'll try to cover. But we'll do it fast, right? Because I'm assuming that many of you people know it. So take it as a refresher. Okay, we'll quickly do it as a refresher. We'll refresh the concept of STLs, right? Okay, so moving on to the STL part. So we'll start with where is this? Huh? Okay. So let me start a new project, and in that we'll start making a lot of STL code and all we'll write, right? So let me do this STL demo I'll write. And inside this, I'm keeping a simple project right now because this is for the STL, right? So I'm keeping a simple project. So let me make this main.cpp here only. And let's create some main.cpp and let's create a simple CMake list file, CMake lists.txt. And let's copy some of the code from the other CMake. We'll require this. Let's call it STL demo. And then what else will require? Add executable will require. And we'll require the sources. So set sources will be there. This one we require. And we only have a main.cpp file, right? Remove this for now, right? This I think should make our demo part. Cd stl demo, make directory build, cd build, and then cmake dot dot. So everything is configured. Now I will start writing the code. So for the code, let's say int main cout indel, that's done. Let's say code started. So that we know code is working fine. This is done. Now we'll do a cmake dash dash build dot. Does order of commands matter in CMake list? It does when suppose you are creating a say add executable, but and before doing add executable, you are giving a target link library, and at that point it doesn't know what executable is. So in that case, it does matter what is the order. But until unless it doesn't know, CMake will tell you, give you the error. But if it knows what is there at that point of time, order doesn't matter that much. See, you can give include directories afterwards also, before also, like that you can do. But the example I gave, in that sense, it will require that ordering. If first it will know what executable it wants to make, and then it will try to link the libraries with that, right? Should have add execution still demo project, right? Uh, 1 second. So let's see if it will build. Code started. Everything is working. Everything is set up. So hi, Amit should have a text to STL demo in CMake list for STL demo project, right? So it's there only, no? I didn't get the question, but okay. So moving on. So for the STL, I'll keep writing some notes here only. Let's keep it here. Okay, so inside STL, so as you know, STL is a standard template library. All the algorithms or containers are templatized. So it means that we can use it for any kind of data types, like traditional data types like int, double string and all, or other data types like classes and objects, that user defined data types, right? So that's why it is called template library. Okay, I'll just say it. This is the cmake list.txt. You can use it. Okay. So this is standard template. So inside the standard template library, what all in categories, what do we have? So we have containers, we have algorithms. What else do we have inside STL? Algorithms, containers, and iterators. Correct. Anything else? Anything else we have that is part that comes from STL? We have functors. So containers is something like vector, or maybe list or map. Everything is like comes under container. Inside algorithm, what do we have? Like sort, search, find, maybe transform. We have a lot of algorithms. In iterator, what do we have in iterators? So suppose begin, or maybe end, and also like r begin, r end, like that. Correct. And inside functors, what do we have? Like we have something called, let's say, greater or less, right? That we can directly use in our code. So these are the top category in the like broader category in which our STL is defined, right? So let's talk about vectors first. Okay. So what is so okay. So let's do like this. As I know ki all most of you will be knowing. So let's do it fast. So let's do it like, let's connect where you can unmute, and what questions we'll be discussing, we can answer it also, right? So in vectors, what is the underlying data structure that we use in vectors? You can unmute and keep telling so that we can go fast, right? What is the
It's a
underlying
dynamic
data
array,
structure in vector?
Arrays.
Simple array.
dynamic array,
Okay. What is
allocated on
dynamic array?
memory. I mean, you try to allocate the memory using heap. I mean, from heap on the runtime. You dynamically
Okay.
change the size of the
Okay.
array based upon the number of elements.
So vector is using dynamic array. So what is the worst case algorithm for insertion, deletion, like CRUD operations? What is, who can tell? For CRUD operations in vector, what is the worst case algorithm, like time complexity?
Order of n
For
for insertion.
order of n for insertion, like insert anywhere, or is it like front
Like
end
if
is
we want
on?
to insert at the end or at specific.
So at the end we can insert in O1, right?
Yeah, yeah, yes.
Right. So what is the watch time complexity? So if you are trying to insert it at some particular place, not the end, then it becomes worst case, you can say ON.
Yeah,
And if you are inserting at the end, it becomes it is O1, right?
yeah.
So this is insertion. What about deletion? What
Again,
about
still.
deletion? What is the time complexity?
If you have to find and delete, then again ON.
And if you are deleting somewhere from the middle or from the front, what?
But if we know the subscript, then it is O1, right? For
Sorry,
vectors. If we know the subscript,
it means you are telling what at any specific place if you want to delete. That's what you're saying.
yeah, because the iterators are random access iterators. So
But
unlike
once you delete it, you have to move the elements also, right?
right,
Right.
but
So
the
it becomes ON if you are not deleting it from the end,
right,
right? Basically, whatever the elements which is after that deleted element, it becomes that O of that many times. Whatever the number of elements it is after that,
right,
right?
right.
Right.
Yeah.
So update is also same. CRUD is done, I think. And what about okay, when you say what about pushback? What is the worst case algorithm for the pushback time complexity?
Big of
One.
Go
n.
one.
It should be n, right? Big of n. Because in worst
Yeah.
case, like let's say our dynamic array need to resize. If capacity is reached, then we have to go and allocate a new double of capacity, and then we have to basically copy back whatever element we already
Yes.
have.
Yes, correct. So worst case you can say O1, but basically when we say the pushback time complexity, we actually say amortized time complexity of O1. You understand amortized, right?
Right. Yeah.
So it is always O1 until unless we reach that particular boundary where you have to increase the size. At that time it becomes ON, right? So pushback has the amortized time complexity of O1. On worst case it is ON.
What is amortized?
Amortized means most of the time it is O1. Only at some places at the near the boundary when you are like filled up the whole vector, now you have to resize again. At that time
Okay.
it just becomes ON. Otherwise it is
Okay.
O1. So it's
Okay.
like in that sense it is called amortized.
Okay.
Amit, one more thing. In case we know that the vector size already in advance, see, suppose something we are actually passing some dynamic, actually the size and all we know that, then okay, it is always good to allocate with that size, right? So that we don't come with
Yes, yes,
this
yes.
kind of an issue.
Yes. If you already know the size, you should always resize it to that many elements,
Okay, thanks.
right? So you don't have to. So again, the time complexity will always become O1. It won't become ON at any point of time if you already know the size, right? So anyone has
Yeah, yeah.
any confusion about this time complexity? So why is this important? Is for 2 points. One is from the interview perspective. Also, this gets asked in the interviews for the CPP. And also, when you are choosing the kind of data structure we can use, there are different kind of data structure you can use for a particular like you are in a situation and you can use different kind of data structure. But the thing is, depending on what you are trying to do, like if your only purpose is to do pushback and if your purpose is to randomly select any particular element, it's good to go with vector. Why? Because random selection is O1 in vector, correct? We can address any element at randomly at O1, correct? So these things you have to keep in mind. What what is the underneath, what is happening inside the vector for every data structure that you have to keep in mind, every containers, so that you know, is it better to use reserve while using vector? If you already know what how many elements that you have to use, suppose you know ki I'm sure that I will be using 100 elements, it is good to use reserve, because then you will save that particular time, like right, when you are doubling the vector size and then you are using that time, right, it becomes over. So it's better to use reserve when you already know some size beforehand, right? So it is good from the interview point of view also. So so if I ask just a simple question in vector, how do you create a 2D array in vector? uh, so suppose, can anyone keep telling like how to create a 2D vector?
Vector of vector.
So I do include a vector, suppose. So I can do a vector of
Yeah.
vector
Yeah. I think
of
Shriyanka has written it
suppose
already.
it is type int. And after that what? Like after that what? Wake of what I should do? So suppose I have rows of n. So suppose int row is equal to, let's say 10, and int column is equal to, let's say 20.
You have to iterate in for loop. Again, take one
No,
temporary
but
loop.
how
One
do we
take.
define it?
Then
What should I write here?
vector of int comma 10.
So you
Sorry,
should
again,
like
get to your
like
question.
this rows, and then
Okay,
vector
there.
of int of columns, and let's say you want to initialize each element with suppose initial value of 1, suppose. So you do this. So this is your 2D vector of 10 rows, 20 columns, and each initialized with 1. And suppose you want to print it. So how you can print? What is the shortcut you can print? There are different ways you can do it. So one thing I can do is, let's say auto. I have written rows now. So let's say row of
Back
with, right? And inside it, what I can write? What
row.
should be here?
Auto pointing to row.
Auto, let's say call it element maybe.
Yes.
And here what I should give?
Row.
Row. And then I can give us
Ele-
cout element, correct?
And then
Yeah.
And you can,
not
yeah,
and then.
you can give a handle here if you want to.
Yes, yes.
And you can leave some space so that two elements are not together, right?
Yes.
Is this okay? Does everyone understand this? This, I mean, this can be used in many of your code, like creating a 2D vector and all. So if I
Yeah.
give a run, and if I run it, you can see all initialized with 1. You can see it, right? No problem till here. Like everyone is okay with this code and everyone understand what is happening, because this code will be used a lot. This type of codes, creating 2D vector, accessing each element, correct? Going on. So if I have to create a 3D vector, then what should I do quickly? Vector of, let's say we have a int depth also.
Vector of vector. And inside that, I think you have to create one more vector.
Vector of vector,
Yeah, inside vector.
vector
Correct.
of, let's call
Int.
it int,
Correct.
like this. Let's call it
Yes.
v2. Let's suppose give it an v2. Then what inside this?
Now we have to define
Depth.
I mean, you have to do it for each dimension, right? So depth and so
Yeah,
on.
vector of int, and then now we come to rows. So rows, and then vector of int of type columns, and then initialize with, let's say, suppose 2. Is this, so does everyone understand this? This is becomes a 3D vector, right? Good. No confusion with this. You can create as many dimensional vectors as you want. Okay, so moving on, let's talk about lists. So std list. So we'll do the same thing. So what is the underlying data structure inside the list? What data structure we
I
are
think
using
it's a
in the
linked
list?
list. I think it's a linked
Okay,
list.
single, double,
Singly
what
linked
kind of
list.
link?
Okay, it's a doubly linked list.
Yeah, it's a double linked list. Okay, this is the underlying data structure that is getting used in list. So tell me the worst case time complexity of the CRUD operations in list. In any one of you, come on, unmute and tell. These things are very important from interview point of view also.
O of n again
For
for insert
So
insert, CRUD,
insertion,
CRUD operation. Unless you have the pointer to the node, then it will be O1.
So, for example, if you are inserting in the front or
so
the
let's
rear,
do the, what is the time complexity for pushback?
1. O of
one, we
1.
go one.
Okay, what about push front?
Again, pop.
Same. We go one. Yeah.
Okay, what about pop back and pop front?
The same.
Same.
I
Right?
think so.
Everyone is getting that picture that it is a linked list that we can directly change the link and we can insert. Are you getting the picture why it is open?
Yeah.
Everyone, right? You understand, if you understand linked list, then you understand if I have to put anything in at the end, there is always a pointer at the end. I can just put it and link it. So it is just open. Or if it, even if it is front, we have a head that we can just change the link and new node becomes then my new head, right? It again it's a open. What about deleting a node at any particular point? Any particular node if I want to delete?
ON.
We go in.
Why open? Why?
Because you have to search and delete.
No, I suppose I know this particular thing I have to delete.
Then open.
Oh,
But
Then
Open?
again
need to.
open.
So you only have a pointer to the head or the first node of that list. So you'll have to
Mhm.
iterate, traverse through the list to reach the end element.
Yeah, so suppose it is like find and delete, then we have to, of course, we have to iterate and delete it. It is O1. But suppose we already know a node where we have to delete, then it can become O1. We can directly delete and relink the previous and the back wala link, right? Just think when you see list, you can think of linked list. So when should we what scenarios we should use list and not vector? Any
When you
particular
don't
scenario?
want contiguous allocation. When you want to avoid contiguous allocation.
Okay.
Or when we want to insert or delete frequently and we don't want random lookup.
Correct. So this is main point. When you don't want random lookup, you can go for list. Because if you are doing random lookup, list is not good. Because it will again keep traversing and it will become ON, right? Can we move on? List is clear and it has all the similar functionalities like pushback, pop back, front, delete, right? Everything is similar as vector, but the only thing is underlying data structure has changed. So your this wash time complexity gets changed, right? Moving on. So after we have done list, we have to see what is std set. Okay, so what is std set and what is the underlying data structure for it? Come on, quickly.
linked
Balanced
list. Linked
self-balanced
list. I told.
One person.
self-balanced BST.
Okay, cell balanced bst. Correct. So std
Yes.
set, or we can also use std map also. So both the same thing. They are using cell balanced binary search tree. So basically BST, but cell balanced. So they have the so everywhere you are traversing till the last point, you can be sure that it will be O of log n. The insertion and deletion, everything will be O of log n. Everyone understand this balanced BST? That the CRUD operations will always be O of log n in watch time case. Correct? And there will be no random access in when you are using set and map. And when you are using set and map, at what places you should use set and map?
Searching.
Anyone?
Effective searching.
Okay. What else?
Like when you want in sorted order. Uh,
Okay, correct. When you
And
want
when
your
we
data
want
to
to
already be
store
sorted,
only unique elements.
okay. So the keys inside the set and keys will be unique. So you cannot have duplicate keys, right? In both the cases, set and map both. Correct?
but there is a multi-set in which we can.
Yeah. I'll come to it. So set and map is clear what is inside cell balancing binary tree, cell balance binary search tree, and everything like insertion or deletion or lookup will always be O of log n, right? And the data will be always sorted. It will always be in a sorted order. Correct?
One question.
Yeah.
Sorted order. What is
There is a
the
lot of background noise. Can
what
you?
is the sorting algorithm, and can I uh, specify the sorting algorithm?
If you know the balance BST, like we are using a binary search tree, like we keep checking on each node whether it is greater than or smaller than this. If you go to the left hand side wala tree or the left hand side wala node, like that. Do you remember how do we use binary search trees? Correct?
But sorted only if you do in order search, in order traversal.
Hmm. Yeah.
So,
Correct. Correct.
but okay.
So that's how okay. So let's do this. So if I go ahead and let's comment this out. Let's say we are going to use set. So let's include set. So has include set, and let's say set of, let's say we are trying to put integers, and let's call it st maybe. And let's say if we are trying to insert, say suppose we insert 10, and let's copy this code 3-4 times. And let's say we are suppose inserted 20, and let's say suppose we inserted 8, not 8, then let's say we inserted 4, right? And if you are trying to traverse through this set, what will happen? So say suppose for auto, let's call it element again, and inside st, and suppose we are trying to print cout element,
Yeah, it will print 4 at 1020.
right?
Yeah.
Everyone agree with this? So if I do cmake dash dash build dot, so can you see when we are traversing right from the start to the end, it is already giving you in sorted order. Whether or not what order we have put in inside inside the set, it is already in sorted order. If we traverse, getting my point. And same thing will happen for map also. For keys will be sorted. Got the point? Yeah, because it is self-balancing. And because of self-balancing, everything CRUD operations are O of log n. Correct? So these things that you have to keep this in mind. Every container that you are using, you should know ki what underlying data structures it is contained of, right?
So Amit,
Okay.
keys will
Yeah.
be sorted in means keys can be string or alphanumeric or something of that kind, right?
Yeah. It can be anything. I'll tell you what other ways you can sort it. So see, if you are not giving anything, it will sort it according to the less than operator, which is inbuilt inside the set or map. But you can give a comparator function. How you want to sort it. That I'll come to it.
Yeah, but
Right?
Amit, here
Okay.
here we got sorted because the iterator is implemented in terms of in order traversal. Because the root, it's a self-balancing tree, so root may have could have any other element, may not be the most least element, right?
So it keeps on sorting. No, the moment inserted 10, okay, 10. One node is created with 10. The moment I inserted 20, you have to go and see how self-balancing binary search tree works. The moment you insert the 10, and maybe at the right node, it will create 20. The moment you
Correct.
insert 8, right, like this,
Yeah,
it will keep on making the tree.
yeah, I get it, but I'm saying that but still the sorted order is coming only because the iterator is going in a in
Correct,
preordered
correct,
round.
correct, 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 correct,
Yeah,
correct. Yeah.
because I was all along trying to
Mm.
think that the root will
Mm.
have could be any element, so how we are
Yes,
getting
yes,
this.
it
So
is. It
yeah.
is in order. When you are traversing, it is giving in order. That's what you are asking, right?
Yeah, that is what I was trying to understand, that the in order
Mm-hmm.
is coming because of the property of the iterator, not because of the tree self.
Mm-hmm. Correct, correct. Yeah. Okay. So after moving on, the similar thing you can do with the map. Shall I give the map also? Like you can make the map for you can do a hash include map. And also one more thing I wanted to show you is, suppose I do a st.insert, and if I give suppose 10 again, we said right, it doesn't take the duplicates. So what will happen in this case is, if I build it again and run it again, you will see the 10 is only once, although we have inserted it twice, but it will only appear once, because that the second time if it sees the duplicate key, it will be discarded. Correct? Okay. So this part is done. And if I talk about map, so we have a map, let's say call map of say, let's call it int comma string. So int becomes the key and string becomes the value of it. And let's say map mp. And we can give it like this. Let's say insert. And insert we can give like this. I think 2 comma, let's say apple. I think it should be like this. Okay. It takes a pair. So this is the key, this is the value. And also if you want, you can insert it like this also. So mp of 2 equal, let's say, tomato. So you can insert. So this 2 becomes the key and this becomes the value. But as you can see, 2 will not be taken again. This will be discarded. So if I go ahead and do this and try to print this, cout element mp, cout indel, it should work. Okay. What was the problem? I have given map, no? I have given map.
Not first.
Element is a pair, so maybe
Element dot first.
Yeah, correct. So element dot.
Dot
So
first.
it's like this: element dot first and element. So first will print the key and the second will print the value. Element dot second. Correct. So if I build it again, build, and if I run it, so it will only say 2 and tomato. Even though I have given it 2 times, the key is 2, it will discard the second one because it only takes the unique values. Correct? So this is done. Okay, so moving on, the similar to set and map, because what we are saying is it only takes unique. If you give the keys the second time the same key, it will discard. So for that, if you want to have multiple keys with the same multiple keys multiple times, we can use multi-set, and similarly we also have multi-map. Everything is same except for the fact that now if you give 2 again, it will again accept it. It will print all the same key. If you have given it multiple times, it will accept all the keys, right? Only this is the only difference: multi-map and multi-keys, multi-map
But
and
what is the
multi-set.
internal data structure here, and how does
Same,
it
same,
manage?
same.
But for duplicates, it stores. How does it store duplicates?
How does it store duplicates? Like if it has 2 key 2, and again if it has 2, it will put it in the like in the same node. It will say it is 2 times and with the particular different values. Again,
Okay,
I think it will be in the list or something that I need to check how they are putting it. But internally, it is a self-balancing binary search tree only.
okay,
But maybe they are using something inside the node, how they are taking the same keys again and again.
right. So, okay.
Right?
Yeah,
But
thank you.
but again, the this watch time complexity will be O login only for all the CRUD operations in multi-map
Perfect.
and multi-set also. Okay, so moving on, we
But again, here
have.
there is a worst case.
Hmm.
It can be on, right? Because for example, I put 10 elements of the same key, then it will have to, as you said, it will have to keep an internal list, and then theoretically, I am just thinking.
No, correct.
Yeah.
We'll see and we'll tell you. Okay. But let's see, think of it like it is internally somewhere, somewhat it is self-balancing by BST. Okay, but for the
Okay.
same key that will look. Okay.
Okay.
Okay, so now we have something called unordered map. Let's unordered set, and similarly we have unordered map. Unordered map. Sorry, unordered map. So what is the CRUD operation for this? Watch time complexity, everyone, and what is the underlying data structure?
Hash map and O1.
Hash map and
Inverse
O1.
case ON.
Yeah. So in hash map, if you know the theory in terms of if it becomes chaining, it can become O of n, right? But mostly in on an average, it becomes O1 in the unordered map. Why? Because it is using hash map internally. Are you getting the point? Hash map. So on an average, it will be O of 1.
But internal data structure will be contiguous allocation, the memory allocation, right? Because hash map is again a abstract data structure only.
See, yeah, hash map, how they are doing it, it could be become different. It could be like, see, suppose on Windows, how they are implementing is, and on Linux, how they are implementing internally could be different, how the hash map is getting implemented. But it will be a hash map.
Yeah,
See,
but
whenever,
the state,
yeah,
yeah,
tell
but
me,
my
tell me.
question is the data structure will be some malloc or some new or something like that, right? Like contiguous.
Could be.
Okay.
Yes, yes. Okay, so this is clear. Unordered map and unordered set. Average will be O1. So whenever you are have a situation where you are just looking for a trying to store a key value pair, and then you are trying to search for that key value, you can use unordered map and unordered set. Why? Because it will mostly have a O1 on average. Like search will be a O1 of average. Insertion will also be a O1, right? So insertion and search, if you want O1, you can use this unordered set and unordered map instead of using set and map, right? Because that will become O of log n. Clear? So similar to this, we also have, so this will also take unique keys and it will discard if there are duplicate keys. So similar to this, also we have unordered multi-set and multi-map. Unordered multi-set and unordered multi-map. Correct? Same. So it is clear till now. Everything is clear. Like everyone understand what is the underlying algorithms, because this will be asked in the interviews. This can be asked, right? Okay. So after this, we have done, let's see what else. Multi-set we have done. So I'm not giving so many examples because I think these are like nothing, like this is not really hard. Like you can do it on your own. So some other example, adapter example. So there are other type of containers which are called container adapters, right? So anyone can tell what are container adapters? Any example of that in STL?
DQ,
Stack and
Yeah.
queue.
DQ, Q stack,
So
DQ.
DQ, okay, sorry, I missed one thing. So one thing I left was, so let's come back to this. So one is DQ. What is the underlying data structure for this DQ?
We can implement W in using W linked list,
Okay.
and we can also implement using the circular array.
Yep. So when should we use DQ?
When we want to insert from both the end, and we want a constant time complexity, right? Like in that case, we can use DQ.
Okay.
With the
Anyone
sliding window
else?
problem, like sliding window problem, like
Okay, how? So how sliding window problem? How is it helpful?
yeah, like suppose we want to delete from start and insert from end. So both operation will be O of n, O of 1 in DQ. So
Okay, correct.
yeah, in this situation, it will be better data structure in the sliding window.
So mostly if you see, it is implemented using fragmented array. What is meant by fragmented array? Like small groups of arrays that is been created for the DQ, right? Unlike vector. So it has an array that is created, and whenever it needs, it just doubles the array, right? And then copy the whole thing into the new array. In this, it has some small sizes of the array, that is fragmented array. And then so if suppose you have to insert or suppose you have to search, you just have to find that first you have to find that which fragmented array it has to go to, and then randomly access that particular place in that fragmented array. So in that sense, it gives a O1 of insertion and deletion on an average. Like sometimes it has to create the new fragmented array if all has been filled up, right? Not clear? Clear? Hello?
Yes, Amit, I think yeah, it is clear.
Yes?
It's
Okay.
yeah, like using
It's clear.
multi array, it is implemented, right? Like it can be one or two array, and then they're implementing it.
Yes, yes.
Okay.
So this is also important. DQ is also important.
Is
It
it
also
a bit,
provides, yeah.
yeah, so is it a bit a different data structure, not classic data structure like what we did with other things? Because this fragmented array, in fact, this was new to me.
No, no, this is similar as the vector or list, whatever. The only thing is how it has been internally defined. Like it has been used, the vector is using dynamic array. The DQ
Right,
is
right.
using fragmented array, right? The way it
Okay,
has been defined internally. And it has
okay,
some advantage, like it gives you a O1 of, so suppose in the middle also when we are trying to insert or delete, no, it takes less time than the vector.
got it, got it. Okay.
Right, because it
So,
has to find one fragment array where it has to insert, and that fragment array is much smaller than the actual when you are using in vector.
okay, okay, okay.
है ना?
Yeah.
Okay, so
Uh,
these are
Amit,
yeah. Hmm.
so if
Yeah.
I understand, like for vector, when you said that this pushback operation has ego one amortized cost, right? So like for example, like if the container is like full, then it will try to create another, it will try to allocate something with double the space, some algorithm like that, right? And
Yeah,
then
yeah.
that it will have to copy over everything
Yes,
from
copy
the
everything to the
original,
new array.
and that problem is avoided in a fragmented array, basically, right?
Yeah, somewhat avoided.
Yeah,
Because again, if it fills, it again creates a new fragmented array, smaller array.
correct. Yeah, yeah.
Yeah.
Thanks.
Okay, so that is done. So now we are talking about the container adapters. So one container adapter is, so I'll just write it. Container adapters. Why we are calling container adapters?
It
Any idea?
uses the existing containers as the underlying
Yes.
structure.
So when you are using Q, no, you can actually give what kind of containers you want to use underlying when you are using Q, right? So Q can be used using vector. Q can be made using list, like that. Q can be made using DQ. So that's why they are getting called container adapters. They are adapting the already available containers, right? So there is Q. What else is there as container adapters?
Stack.
Stack, correct. What else?
Priority queue, maybe.
Priority queue.
Yep, correct. Priority queue. So these three are famous container adapters that we use. So inside this, we can give what kind of containers we want to use to store elements inside queue or stack or priority queue. Correct? Right? So this is done. So we have mostly talked about containers now. So let's do a simple exercise. 1 second. So multi-set is done. Priority queue is done. So by default, how the priority queue stores? Is it like, have you heard about min heap, max heap?
Yeah, yeah.
So what is
Max
max
heap.
heap? What is min heap? So suppose let's do this like this. So suppose I have I think priority queue is inside queue. Priority queue, right? So I will do what I'll do is I'll just comment these things out, right? And let's write a priority queue here. Priority queue of, let's say, type of end, and let's call it PQ. And we do PQ of, let's say, insert. It's insert, right? Or no, PQ dot Push. Okay. PQ push and pop is there. Just like queue and stack is there, no? So push and pop, right? So suppose I push, suppose 10, and similarly, if I copy this, copy, and let's say I'm pushing 20, I'm pushing, let's say 8, and I'm pushing 40. And now if I want to print this, so for suppose for, we can do it like this, while not of pq dot empty, right? So until it is not empty, we want to print out, see out what is on the top. So pq dot top, right? And let's say endl, and then we also pq dot pop, right? And so, acha, empty is a function. So this is done. So what do you think? What will get printed after this? Once we execute this code,
Descending order.
descending order. Everyone. So build it.
What is the default comparator?
See, 40, 20, 10, 8. So this the way we are doing, if we are not giving anything, it is actually a max heap. Max heap means the top element will always be the greatest element, right? So suppose we want to change it to min heap. How can we change it? So we want the max element, the smallest element is always at the top. So how can we change that?
By adding the second template to change the default comparator.
Okay. So what can we give?
That I don't. A greater.
Greater int.
Greater of int, which is already like defined in the STL. So if I just give this and then build again, what is this? Is it defined somewhere else? This point.
Algorithm. Include algorithm.
I think this is not defined. Should be defined somewhere. As include algorithm. This not this.
Some syntax like vector of int, comma, greater int, like this, no?
One
In
sec.
the second argument.
Vector Q. Which one?
Vector of int, comma, greater int, something like this. Like after int, comma, vector of int, comma,
So
greater int,
we
something
want to
like this.
give the what is the storage also, right?
Yeah.
Yes.
Yeah. Right.
So that is always the third argument. If we are not giving, it assumes. Let's see. I think it is like that. Yes, it builds.
Wow.
I run 8, 10, 20, 40. Now the smallest is first, right? So what happened here is you can, if you have to give the greater int, you also have to give what kind of underlying storage what you are using, right? Like I said, it is a container adapter. So that's why it was giving error. Got it? Everyone got to this point why it was giving error? Because you
Yeah.
have to give what kind of storage that you are using for this priority queue. If have to use this, you have to give the second argument also.
Right.
I have a
Correct?
question.
Yeah.
So you said max heap and min heap, right? So is that like the new keyword and the memory that's assigned on the heap?
No,
Is
it
that
just
what
think
is
of it.
being used
So
here?
it's something related to priority queue. This element terms that has come. So max heap is like this particular priority queue. Whenever you access the top element will always be the greatest element of all the elements that it contains. That is max heap. And the min heap, when I say this priority queue is min, we are using it as a min heap means the smallest element will be on the top. See, we are doing the top, right? Every time.
Yeah. So this has nothing to do with like dynamically allocating memories or
No,
anything.
don't think like that. Don't
That
think like that.
okay.
It is term associated with the priority queue. Whenever you use priority queue, we say, are we using as a max heap or a min heap? Whenever you say max if, top element will be the greatest. Min if, least element will be at the top.
Okay.
Okay.
That's
So sometime you need to use it like this. Okay, at this for this situation, whatever we push, we always want the least element at the top. Or whatever we push, what I always want the greatest element at the top. Right? Correct? Okay. So after this,
yeah.
I think Q and stack we can leave, right? Everyone knows how to use it. Q dot push, Q dot pop, everyone knows, right? So moving on to algorithms, if I quickly go ahead with the algorithms. Okay, so so let's see. So suppose if I have to use STD sort. Okay, so suppose I have to use STD sort. How can we use it? How do we use it? So we say sort. So it is the
Um,
start iterator.
Iterators, yeah, begin and end iterators.
Yeah, and the end iterator. And it could be with anyone, like vector, list, anything, right? And what is the third thing that we can give in the sort?
Function.
Comparator.
Okay, comparator, right?
Comparator. So what
Lambda
kind of
function
sorting
which
that we need? We can give our own sorting algorithms, right? So if we don't give any comparator, what kind of sorting it will do
Ascending order.
by default?
not
Ascending.
sort.
Ascending, right? And if you have to give in the descending order, what I have to give here?
Standard
Same,
grade.
greater in, same, like this. Suppose it isn't greater in, right? So similarly, we have a find. So you can give what again similar start iterator, end iterator, and what particular element you have to find, like start iterator, end iterator, and the element that you have to find. Right? It will give you the iterator where it found the element. Okay. So if you go to so suppose how do we actually give this algorithm is you always say find. Say suppose we are trying to find in the vector suppose. So we always give vec dot begin. So this is the starting iterator, vec dot end, say ending iterator. Suppose inside this we are trying to find suppose it, and it will give me some kind of iterator. Let's say auto IT. So we found it or not will depend on we'll do this. So if IT not equal to vec dot end. What does this mean? What does this mean? That this kind of code you'll see it lot. I'll see a lot in the STL.
That the element was not found in the data
Yeah.
in the vector.
So whenever it is not found, this iterator will point at the end of this particular whatever the iterator is, this vector it is given. No, so it will always go to the end. So it means that you have not found this element. Okay. Correct. Okay. So find is there. I'm going quickly, right? So that whenever we have to use it somewhere, then we can do it discuss in detail. So another search thing is binary search that that people use. So for the binary search, what is the prerequisite to use it?
The container must be in sorted order.
Yes, the container must be sorted so that only then that binary search can be applied. Correct? So there is something called reverse. You can reverse the whatever you have given inside the. So you again it is same like you give the first iterator, second last iterator, and then you do the reverse. It will reverse all the elements between that range, right? See, whenever you are doubt, you can stop me. I'm just trying to go a little fast. So another very important thing is STD accumulate. So you give the begin iterator, end iterator, and some starting value where for which you want to converge, right? So suppose I give 0, right? So I just want to take one question for this. So suppose you have a vector of end, let's call it v2 something, and let's give it some element here only. So let's say 4, 7, 5, 10, right? And if you want to sum all this, how we can directly do it? Well, we want to sum of all these elements. How you can do it? I
We
can
can use some
directly say,
SD accumulator also. Yeah.
yeah, you can directly say accumulate. I think this accumulate is in header of has include numeric. So accumulate, now it should find v2 dot begin and comma v2 dot end, and the third element is the starting, whatever the initial value, accumulate, and then I think we can take it in the result, right? And then we can do cout result. And if you run this, no matching overloaded function found. What did I miss in the accumulate? Uh,
Does it expect some lambda function which will?
no, that we can give, but not necessarily it expects. What did we miss? V2 is that this one, V2 dot begin we have done. Okay. Think I do this. Accumulate, we requires vec dot begin, vec dot end, and the initial value, and it should accumulate all the things and give it inside the result. What it is we say, no matching overlaid function found. It is saying, let's see what is there.
It needs some functional also. No, right?
I think we are missing some include file.
Yeah, it actually the functional you can try functional.
I think it is in numeric only.
Okay.
Has std included. Let me see once on net. Where is std accumulate is accumulate. So it is inside defined inside numeric, right? And
Yeah.
let's see any example is given. So this is vector. So it is doing this, right? Let's copy this. And let's say suppose we do this. And so see out, let's call it sum. And if I try to run again, okay, it builds. What are we doing wrong?
It was same only. I don't know.
Find V2 again,
Can't
I
you
think
do
so.
Control Z because it's very strange. Because the same code.
Yeah,
Okay,
but I
anyway, it
think
is giving 55. That let's do it Control Z and let's see what was the problem.
I think
V2,
you
did
have
we
not
do?
written that
you
STD.
defined V2 again. V2 is defined on top as well. So that's the
Let's see.
issue. Not
Okay,
here.
correct.
Okay.
That's what I thought. What was the problem?
No.
But
Now we need to change that to V3. You changed V3, but again you are using V2. Okay.
Change in the accumulate also. V3.
Correct.
No, here in
So
the
now it is
line
done.
number 90.
So now it is correct, right? V2 here and everything V2, and now here it is V3. Sorry, here it is V3. Now it is correct, right? But anyway, you understand what is happening, right?
Okay, here one doubt.
Huh.
Okay, what? Okay, for this, right? For the accumulate and all, right? Okay, we can also do like a common for loop or like means range based for loop, right? Is it
Yes,
anything
yes.
performant or something like that compared to that?
See, it is not about performance right here, because anything it will be doing is it will be passing on to each element inside this range and then accumulating. Only thing is it is very much configurable, like what kind of accumulation you want to do. So suppose you want to actually give a lambda here, to decide ki what kind of accumulation you want to do. So suppose it takes two things. So let's say suppose we want to do the product of all the elements. So I think it takes two things, product and end element, suppose, and return prod into element. Let's see what it gives. So what I'm trying to do here is I'm trying to
But
multiply
you need to make
each element.
the initial state as 1.
Correct. Initial state as one because it will again because it will multiply it by zero and make everything zero. So this is done. This is here. It is done. And what did I miss? Anything is not closed. Okay. This one I didn't know because semicolon. Correct. So let's see. If I do this, build, see 1400. So 50 and is it 1400 multiplication of all three?
Yeah.
Yeah, it's right.
200 into 7, 1400, right? So the thing is, you can do anything here, right? You can do anything to accumulate all your elements. So it is very much generic that you can use for inside accumulate. Correct? Does everyone understand this? How we are using this lambda function?
But Amit, the underlying time comes to be same, right? Like for accumulator, it will go through like one element and then we'll do.
Yes. It will go through each element inside this particular range and keep accumulating whatever you are trying to do inside uh, this function, right? If you are not giving it, it will automatically add. So by default, it is adding,
Okay.
right?
Yeah.
So you can whatever you can think of, you can do it here. What the way you want to accumulate, right? So moving on from accumulate, we have std count also, and I'll just keep on writing and move forward quickly because I wanted to start with multi-threading today, but I don't think it will happen. So STD, but is this helpful? Because I wanted to take this because it is also asked in interviews. Is it helpful to go through this STL once?
Yes,
Yeah,
Amit,
yeah.
it's helpful.
Okay.
It is like
Like
brushing up for the DSA
yeah, and
ones.
also I'll also give some complex things also. So just wait for 5 minutes. I just want to quickly refresh everything, what all everything is there. So okay,
Actually, this
so
is very helpful because you almost
hmm,
covered from all the main things from effective
hmm.
STL book.
Okay, I have not read, but I just wanted to include everything which is mostly used in day-to-day projects, right? So this can be used.
Amit, one more
Okay.
thing.
Hmm.
Okay, about the pushback, there is also called as in C++11 templates back that can be
Yeah,
used,
yeah.
right?
I'll come to
When
that.
you have
I'll
a
come to
yeah,
that.
okay, okay.
I'll come to that. So we have std unique to get all the unique elements. Okay, so remove. So I wanted to come to this std remove. This is important. And std remove if. Okay, so what does remove and remove if does? Any idea?
Remove if you can pass a lambda or a functor
Hmm.
to change the behavior
Hmm.
on a
Okay.
condition.
Change the behavior. What
Means on
behavior?
a condition basically, like you can add a condition that only remove if a certain condition is met. So you can add some behavior.
Mm-hmm.
Remove
So
will
is it
return
like
the equation. Okay. Yeah, so if we want to remove an element, it will not actually remove it, but it will just return an iterator. So it's upon us if we want to actually remove it or not.
Yes, correct. That's the correct answer. So let's see the example here. So this is inside algorithm, which is correct. I have taken a vector. So just tell me what will be the output. So suppose we have a vector. Let's create a new vector of ends. Let's say we have something called anything like 4, 6, 8, 9, 10, let's say. And what we want to do is remove uh, what we want to do is we have given is remove, right? And we have to give the range. So we have to give wake dot begin, and we have to give wake dot end, and what elements we want to remove. So suppose we want to remove 9. So it will give me an iterator. Does everyone understand this? What I'm trying to do? So I'm using remove. I'm giving a range, and I'm saying in this range, remove the element wherever 9 is there, and it returns me an iterator. And where is this iterator will point to? Where will this iterator will point to?
9.
This iterator will point to 9. No,
It will move 9 to the end and then point it there.
correct. So whatever it has, so what remove and remove if, remember this, remove and remove if both. Whatever things it has to filter out, it will take everything and put it at the end of the range, whatever range you have given, and it will give the pointer to the first element from where the everything has to be removed. So actually after this, it will be 4, 6, 8, 10, 9, and it will iterator will be pointing to the 9. So what we can do after this is, if we want to totally remove, what we can do is vector dot resize to, we have a something called distance inside std, and we can give vec dot begin comma it. Does this make sense? What do you think what is happening inside this? Let's
So
call
it
it
is
vec.
resizing the vector to the size of, like, say,
Correct.
It's calculating the distance between the begin, which is at the start of the array, and then it is pointing to the element 9, calculate the distance, and then resize the vector to that.
Yeah. So if I have to print all the elements, so suppose vec4, I hope there is nothing called vec4 now. And if I do a cout of all the elements, and so what do you think will get printed?
4, 6, 8, 10.
I think 4 is here, I think, and then 6 at 10. We did not give Endel, no? Yeah, that's why. But you understand the point, right? This is done. This is done. So 4, 6, and 8, 10, 9 is removed. So see, once you do a remove inside this range, the iterator is, see, that element is not removed. Element has just gone to the end, and it points to the end. The iterator which it is returned, it is giving that particular point. Now to actually remove all the elements which I have to remove after this remove wala code, we actually have to do this. We have to resize our vector, and resize from where? Like from begin till the iterator which it is pointing, because after that everything what I wanted has to be removed, right? So with these two, you can you can filter out all the elements which you want to remove. So after this vector, everything you wanted to filter out has been done. Like vector will be removed, vector will not have those elements, right? So this is very common code that people use to remove elements. Got it? Is there any confusion?
What is the reason of this behavior? Like, is it efficient? Because eventually they still need to bring all the elements down, right? So what's the advantage of this behavior of remove?
Advantage, maybe at one go you can remove everything. Like when you are, see, so in this, right, when you are doing resize, see, suppose in this remove you are removing one element, right? But suppose in remove, if we are doing a particular, like everything which is an odd number, you have to remove all the odd number. So what it will do is it will keep picking all the elements, it will put it till the end, and then in one go you can remove all the elements. That will become O1 when you are removing at all at once using this, right?
Okay.
Okay, do you mean to say we have something like a move zeros and ones, means move ones at the end, kind of a one, this is there, right?
Yes.
One
Yes.
problem
Yes.
kind of.
Yes. So remove everything at the end, and in one shot, everything is removed. Like you are just resizing the vector. So maybe that is already, maybe that is there in the memory, but in my vector, that is not there. That is not a part of my vector now,
Because what
right?
I was thinking is like if you are just randomly, you still need to keep it in the order, because if you are just moving the ninth element to the last and the last element in place of nine, then there is some efficiency there. But if you are going to retain the order, then it is not going to help much in terms of efficiency. But
So suppose I have to remove 5 elements. I would be removing one and then reordering. I would be removing two and then again reordering. Right. I'm just thinking how would I have done if I would not have done it using
do a
like
quick
this, right?
test. Can we do a quick test by removing 8 and seeing that will it be 4, 6, 10, 9, or it will be 4, 6, 9, 10, and 8?
So, sorry, come again.
Yeah, if we try
Do
to
you want to
remove
8?
8, and then we run through the iterator without the resize and see, or with resize, we see if it is 4, 6, 10, 9, or is it 4, 6, 9, 10.
Okay. You don't want to do this, right?
It doesn't matter, but we can see how it how is it just doing a swapping, or is it doing the the reordering also?
I think
Let's
it'll
see.
retain the order.
4, 6, 9, 10, and 10. What did we do? We are removing it. 4, 6, 9, 10. Are we printing anything else?
No, because we didn't remove resize. That's why 10 is coming 2 times. So
So if we don't do resize, it is iterating through this vector. So it is doing 4, 6, 8 has gone to the end. So 10 is there. 4, 6, 9 has come and 10 is there and 10 is there because 10 must have moved there. So it has done resize. It already knows that my size is only this much. So 5 size is there. So it is just calculating till 5 size. Are you getting the point? Why it is giving 4, 6, 9, 10, 10?
yeah, because I think that 8 has been removed and it has not gone to the end. 10 has been retained there, and the
No,
rest of the
8 has gone till the end, I think.
but then it's not printed, no? Like
No,
if
because
we build the code before running?
see 8 might have gone there and then 10 would have been here. And after that, I think 8 would have been there after 10. But because my vector size is 5 only, it will only print till 5 because I have not resized. Because
okay.
originally the 5 elements are only there, no?
Okay.
Okay, let's play with it, I think. But you get the point. How can we remove
I
the
get the point.
elements?
If we have time, otherwise it's okay. I mean, I was just curious, so I asked, but we can go to the next.
Fine, fine. So, what other things we can do is, suppose we have something like 4, 6, suppose element as 4, 6, 9, 10, and we can give 12 or maybe 56, something like this. And what I want to do now is remove if. And in this, I want to remove all the elements which are greater than 10. Now my question is, I want to remove all the elements which are greater than 10. So how can we do it,
We can use a lambda function.
right? So what we can do here is we can give a lambda, right? And what we can do, what we have to give. So
We
we have
first
to give true. We have to return true only for our filter. So our filter is our number should be greater than 10. So we have to return true only if our number is greater than 10. So it will take one number. Let's call it, let's say x. So if return x is other, if it is greater than 10, then return true. So if it is returning true, it will put aside all the elements at the end. And after that, we can again do resize. Right? Let's see what does this print. So it is printing 4, 6, 8, 9, 10. So whatever number which were greater than 10 are all removed. So 12, 56 are removed. Correct? Correct?
Amit, can you also try uh, return if x percentage or like modulo 4 uh,
You want to change
equal
the
to 0?
problem statement?
Yeah, let's just
So you want
so
to do
divisible by
this.
4 or whatever you like. Yeah, maybe.
So
Yeah.
this is divisible by 10.
Okay. All right. Yeah.
Okay, let's see. So can you see now?
Yeah.
Right? 10 is gone.
Yeah.
Okay. So now so everyone is clear with remove and remove if. This will be very helpful in many of the code you will write. Remove and remove if. Right? And okay. So one more thing I wanted to tell was so one thing was max element and min element that I'm leaving it for now. That everyone I think can do it. Two
Stud
more.
transform.
Yeah. So now the next operation what we'll see is STD transform. So what does STD transform can do? Any idea? When do we use it?
Uh, it's used to apply or basically transform each element. It's like the equivalent of map, I guess.
Okay. So suppose inside this vector, I want to double all the elements inside this vector. So
Ah,
how do we do it? So you can transform all the elements in a given range according to some kind of functionality you want to add, right? So suppose you want to transform. So it is already so it is also inside the hash include algorithm and transform it. What it requires is first the range. So suppose I give wig4 wig4 dot begin wig4 dot begin and wig4 dot end, and next is what other things that it takes, what other things that it takes.
Lambda.
So what it takes is after transforming where I should put the results, right? So it takes that. So suppose I am trying to put result in this, so I will give res dot begin, sorry dot hmm, res dot begin, and what else, the lambda or any function that you want, how you want to transform. So suppose I give lambda only, and I want every element should be doubled, right? So suppose it is taking int of x. So what I will be returning is return x into 2. Okay, so what problem it is giving? Wake for dot begin rest dot begin. Okay, it requires whatever it already requires what size it has. So rest dot. So after with this range, it will require key what is the actual size of after doing this manipulation or transformation, what size, what kind of size it will be having, like what size it needs. So we need to have particular size for this result. So what size it is? So we can give a size of res dot resize, right? Or what was that? Res dot. Okay, we can initialize this with
so
vec 4 right, vec 4 dot size. Let's so we have already told how much size is this, and what is this race string must have a class type, it has a type, and why it is giving problem? Transform, are we, or we have
The
already used it
semicolon
somewhere?
of transform.
Maybe let's change the variable name. I don't know whether I've used it or not. Okay, might be somewhere I might have been using it already. Okay, so return 0. This one's done. return is 0, this is happening, and after transform this, all my results which is doubled should come inside this. So if I do a for loop of auto it and wait for, no sorry, result, and then do a cout and print this and do a end, right? So let's see what this print. Okay, so we have getting a print of, so our was 4, 6, 8, 9, 10. After we have done this, I think it is double, right? So from here 8, 12, 16, 28, 24, 112. 8, 12, 16, right? Done, right? Transform. We have doubled all the integers which are inside this vec4 using this transform command. So similarly, you can do anything you want inside this particular code, inside this lambda, right? Is this fine? Transform is fine?
Yeah, just two questions. One, can we use vec4 only in third argument? Can we change the same collection or no?
If you are going to change the same collection, let's see, and does this create a problem? If I give this, we have done the build, and if I do this, see.
No result. You're iterating through result. You have to iterate through vector 4.
Vector 4. Okay, so what we are getting is 8, 12, 16, 28, 24. 8, 12, 16.
So it works.
It works. Okay. Okay. So it is inside, creating inside the same vector only. So whatever
Okay.
you give, you can put it here. Whatever, wherever you want to put the result, you can give that as a third argument. Okay.
And this instead of int x, does it make more efficient if I send int ampersand x, that is reference? Like does it? Because I think in modern C++, these efficiencies are already taken care by compiler. Do you have any clarity on this, or it is compiler dependent, or what is?
This int ampersand x you are telling, no? So whatever it is sending. Not sure what is it efficient or not. Let me check. I'll check this.
No,
Whether it is efficient or not.
No, it might be efficient also, but as he already mentioned, many will be optimized by the compiler also, I believe.
Yeah,
They
yeah,
will
yeah.
be
I have
happens,
also read
yeah.
something like that. Yeah, that's all.
Yeah, that happens. Yeah, compiler also optimize the things. Also depending on what compiler flags you are putting in.
Because what happens is sometimes people write code review comments on these small things, and yeah.
Correct.
No, what I heard is there is something like a temporal locality and then like this spatial locality, and if you have that value, then the compiler also might optimize also. They might put in the registry and other things. Something I heard, not very sure.
Okay. Thank you.
Okay. So I think I'm taking, I mean, the STL is done from our side, like my side, it is done. Whatever else will, if we need anything else, that will happen during whatever project we'll be doing, no? At that time only, if we require something, that we can discuss the STL at that time. So is this a good refresher? Like, okay, now we understood these things, internal and everything. Was it a good refresher for STL? Because we'll be using a lot of STL things, no? Containers and algorithm. So that's why I wanted to like take this up. Okay.
Yeah, it was a good refresher.
Okay.
It's super helpful. Yeah, thanks.
Okay, and believe me, it gets asked in interviews, C++ interviews. Okay, so I'm just giving a problem statement that you guys have to do. At least you also do something from your side, and let's
Amit,
discuss this on. Yeah.
just one question. Since you also had like functors on this list, right? So this so you had with lambda functions you have this notation where you have these square brackets and then you have like round brackets, and so could you just like maybe tell a one liner about
Okay,
Like
so when
if
you write
something
the
is used
lambda
for global
function,
scope and local scope, but
yeah,
I've
yeah.
like completely forgotten.
Yeah, I'll come to it, tell you quickly. So this first square brackets are for capturing variable. So suppose you want to use vec for inside, suppose inside this code here, right? So directly you cannot use it. If I just give it like this, you cannot use anything inside it. It will start giving you compilation errors, right? Whatever is inside what you are using, you cannot directly use the outer variables inside this. So if you want to use it, you can give these things inside this capture way. So suppose now I give this vec4 here. So it means now that I have captured this inside, now I can use this inside our algorithms vec4. So are you getting my point? So whatever
Yeah,
you
got
give
it.
inside square bracket is for capturing the variables that you can use inside the inside your lambda functions. So similarly, you can give as many variables as you want from outside. So suppose you want to use suppose other like results or anything like that, right? So this is one thing.
Understood.
The second this bracket is for the parameters that will be passed to the functions lambda function. Correct?
Yep.
You also
Yep.
have this return type that you can define like this. So suppose this lambda function return int. So you can define the return type also. But if you don't define, the lambda will automatically assume from whatever you are doing inside it. So from the algorithm, it will deduce what is the return type. Right?
And
Now,
if supposing you have let's say you had some int variable outside, and I want to capture it by reference, then you put an ampersand there,
ampersand,
right?
yes. So suppose you want to capture some other variable you as a reference. So suppose you put it ampersand and then that variable. So now whatever you change inside this algorithm, inside this lambda, if you change anything, that will be reflected outside also.
Got it. Yeah, okay, cool.
Got it, right? And if you want to capture everything, every outer variable, if you want to capture, you don't want to give separately each variable, you can just give ampersand like this. So it means you are capturing all the variables as a reference. And if you give equal to, you are capturing all the variables as a copy.
Okay.
Right?
Well, and to just to add one more point. Okay, now it is a plain function. If it is a class member function, and if you want to access a member variable, then you can also have this inside.
Correct. Correct. You can put at this. There, right?
Sorry, but I have one small doubt in the capture list. When we
Sir, your voice is little down. Can you speak louder?
sorry, Amit, is it clear now?
Clear. Tell me.
Yeah, Amit, in the capture list, right, whenever we send through reference, right, is it not a case sometimes the variable might, scope of the variable might closed? We might using that lambda function after some time. Does
Correct.
it
This can happen.
cause?
This can happen that you have to be wary of, like where you are using those. So that's why it is recommended that you only capture those variables which you know it will not be, like not be in deadlock. No, it is there in the memory. So that can happen. That you have to think about.
Got it. Thank you, Amit.
Right.
I have been asked this question, like what is the backend implementation of the Lambda functions in Adobe Interview? So they really wanted to, listen from my side, like what is the implementation, how Lambda behaves internally, because we are just writing one-liner, right? And how C++ compiler interpret this thing, and then they want me to explain everything.
Okay, got your point. Like it's kind of anonymous function the way the compiler sees it. But yeah, like more about theory that we can discuss. Maybe you can put it on Discord. We'll check.
All right, thank you.
Yeah. So, so one problem statement that I've given that everyone has to do today. At least now, people, please, you have to do this. Where should I put it so that everyone can do it? I'll also put it on Discord today.
Discord. Yeah, in the
Yeah.
homework section.
So this will require a good amount of STL containers and algorithms and all, right? I'll give you two problem statement that I'll put it on Discord today only. Okay,
I think
please, everyone, at least try it.
words are tightly, coupled
That
with-
don't worry about it. I'll put it on Discord. Correct?
We will
After this
also
class, I'll put it on Discord.
we will also add it in a doc. So for those who will be watching recording, for them also it will be accessible. We'll add it in a doc as
But please, everyone try this because this will really give you a understanding of how STLs are getting used, which STL you need to use and everything. Correct? Okay, so I'm stopping the STL topic from for now. If anything you have confusion with, you can please put it up on Discord. Mithun, you can also put some of the things you have asked. That was some good questions. Can you please put it on Discord that I can also check afterwards?
But you answered all the questions. I don't think there is any open question left.
Okay, but anyway, if some confusion is there, anything that we have not even taught in the class also, that you can put it on Discord. I mean, even I would like to look at how someone asked, right, how lambda function is implemented internally, or that I can also look into it.
That actually that is implemented like functor or function object. That is the
I
internal
think the
implementation.
compiler basically creates a class, whatever. Right?
It's kind of concept of closure in JavaScript, I guess.
The overload the off operator. So that's the typical implementation, and all these parameters they eventually become member variables of that class.
Yeah.
So that's the internal implementation.
Okay, good. I mean, everyone should look into it. Like someone said, it can be asked in interviews. Correct? So, should we start with the multi-threading now, or you guys want to start fresh from tomorrow? Because we have 5-10 minutes. So, should we start?
Yeah, we can get a heads up. So tomorrow it will be a slightly better.
Yes, Amit, we can start.
Okay. So let's create a new project where we'll keep putting our code. So let's call it multi-thread demo. Okay. So now inside this, we'll create a simple main.cpp file, and we'll write our boilerplate code and cmake list, cmake lists.txt file. Let's copy it from our STL demo and put it here, right? And inside our main.cpp, let's say multi-threaded demo. That's it. Everything I should suppose means everything is set up. Now let's go to multi-thread demo. Let's create a build directory, cd build, and let's say cmake dot. Okay, so while it is building and all happening, so let's clear up with the theories and all. So anyone can tell what is thread and how is it different from process? Like this is a very common interview question that gets asked. So can anyone tell what is thread and how is it different from a process? Come on. Anyone?
So thread is a lightweight execution of a process. Like with process, it is like bit communication, inter-process communication between the process is bit heavy. That involves the kernel operations. But when it comes to the thread, the communication between them is easy. Also, context switching is easy. I mean, context switching doesn't bring a good difference between process. Yeah, it's like more of kind of lightweight thread execution and using the CPU utilization more.
Okay.
And giving interactiveness, more interactivity to the user application. Yes.
And
they share
what?
a. Sorry, go ahead.
Yeah, no problem. No. The one more thing is actually the thread, a process, right? When we say about the process, an operating system creates a new memory. It creates a new separate sets of memory, and then it will start. But in case of a thread, it resides inside the process. it uses the process memory. But in
Okay.
case of process, it creates its own new memory space.
Okay. So for a process, we can have different kind of memory stack, heap memories, right? Some
Yes.
static, what do you call global memory and all, right? And a
Yes.
code memory,
Yes.
right? But for a particular thread which is inside a process, we have their own stack for each thread.
Yeah.
Correct?
Yeah.
Right? So thread is inside a process. Thread is a part of a process. Right? We can have n number of threads per process. Right?
Yes.
Does anyone have a confusion about theoretically what is thread and what is process? Does anyone has a confusion? Because
Amit,
I'll
can you repeat?
yeah,
I'm completely new to this topic.
multi-threading.
Yeah.
Yeah. So see, when you say a process, what is process? Some see like what we are running here, no, that the .exe. So that one particular executable is a process. We are calling that as a process. One particular application which is running one particular application, right? So suppose this if I'm running this .debug. So this executable, what I run empty demo.exe, this is one particular process. So when you run a process, the OS assigns you some memory, right? And that includes some stack memory, heap memory, code segment, and data segment. So these are four different categories of memory that OS assigns to your process, whatever you are running. But now when it comes to threads, inside the process, we can have n number of threads. So suppose in this code that we have written, this is a main function, right? That any program in C++ starts with, right?
Mm-hmm.
So inside a process, at least by default, there will be a one thread, which is that thread which is called main thread. Like it starts from the main function and it goes step by step from first line, second line. It goes step by step and executes the code. So this also you can say it is kind of thread inside a process. So this is so any thread that starts with the main function, that is the main thread for a particular process. But for a process, we can also have more than one thread. So this is one thread, but we can write a code to create more threads inside a process. So what is the code? How we can create new threads inside a process or inside? Suppose here I want to create a new thread. Anyone? How can you create new threads?
STD thread.
We use hash include thread. This is the library, and this has come from since C++11. Before C++11, if you have to create the thread, you had to use system calls. Like for Windows, the system API call is create thread. And on Linux, or if you go to Unix like system like Linux, you have a library called pthread, and the API to create it is pthread underscore create. So before C++11, if you are using before C++11 compilers, you will have to write separate code for creating threads in C++, right? But after C++11, in the standards, CPP standard, they have given the STD thread that you can use to create the thread. Internally, they will be using the system calls only, if you see. So on Windows, if I'm using the API to create thread using standard library, internally they will be using the on Windows they will be using create thread. On Linux they will be using pthread underscore create only. But as a user, if you are using C++11, you don't have to take care of it. That the Windows or Linux will take care of it. This STL library, this standard library will take care of it. Correct? Are you getting the point?
Yeah. So I just have a one query. So now
Yeah.
before C++11,
Mhm.
to write a thread in a portable way, we should have written
Yes.
some wrapper classes, which
Yeah,
matters
correct.
on that if it's on Windows, you call some create
Yes,
thread
yes,
or blah blah, or a POSIX
yes,
thread for Linux. Now
yes,
this is a wrapper itself. They are available with the C++11. We can use it.
yes. So think of it, very simply think of it is that standard library has given us a wrapper, right? Everyone getting this point that why before C++11 you have to write different codes for creating threads?
So basically, like the standard library gives OS or like free of OS, kind of an abstract way to create the threads, right?
Yeah. So actually, what happens is, so when the people who are in creating this CPP standards, they will define ki, okay, if I do thread like this, they should create a thread. And now, after the standard has been created, it has been put out to the world. What everyone will do is, like Windows, the Microsoft people, they will see the standards created by the C++, and use they will use that standard and create how the algorithm will be. It will be up to them, right? So on Windows we have the CL library, right? Sorry, CL compiler, and the library is called MSVC, like Microsoft Visual C library, something like that. On Linux we have the threading library that is getting used is pthread, right? So the standard is created by some person. Okay, if I write this, this should happen. But how actually this should happen will be taken care by either Microsoft developers or Mac developers or the Linux developers, right? So internally, algorithms could be different. But when I write this for a user, it should happen. This thing should happen, right? Okay. So now going ahead, to create a
Is
thread,
it
Can you
compiler
explain
dependent
what
or
are the
OS
uses?
dependent?
one person. Yeah, tell
Okay,
me.
one doubt. Oh, sorry.
Hmm.
Okay, please.
Go ahead. Go ahead.
No, Amit, okay, again, I had a one doubt. So then, okay, it means that, okay, when you see now, if you are in a Windows and this thread is there, so this is implemented by, okay, internally in the Windows, and it will might call a create thread. But the same thread library, if I see in the Linux, it can be a different implementation file itself, right? So which
Yes,
actually
yes.
call a POSIX thread.
Yes,
Or
correct.
if they have or if they have the same code, and if they have like if def based on that it is there, or I don't
No,
know
no,
how
no.
is that. Yeah.
No, so when you have a hash include thread, in fact you can go inside this also. Go to definition. If you see the thread, I am inside thread.h, and if you see a lot of things are here, but if I go here and see what is that thread class is there, no? Some thread class should be there. See,
Yeah,
if I
yeah.
see begin thread X or something is there, it is all Windows system calls.
Yes,
You
yes,
can
yes.
actually go ahead and see all those. So there must be some class thread must be implemented somewhere. See, class thread is there, right?
Yeah.
Can you
Correct.
see this?
Correct.
An ID and thread constructor is there. So it's
Yes, yes.
something, so from CXX20, we have something called JThread also, if you know,
Okay. So that means
right?
this piece of code will never see in the Linux, but
No.
this maybe outside we may have, but this like begin thread or something or create thread we may not have in the Linux
No. So
implementation of that
see,
thread.
when I did a go to definition on this Windows, it came here. But if you do on Linux, it will go to the pthread wala library, where it will be doing pthread create and all, instead
Hello.
of doing
Yeah.
begin
I
thread and
need
all.
a clarification on this
Understood.
side.
Yeah.
Is it based on compiler or based on OS?
It is based on OS, like, and on OS it has different compilers.
So it is the responsibility of OS to provide this thread implementation for the thread library or the compiler.
I believe it is for
See,
compiler.
yeah, see, when you download the compilers and all, no, so it comes with all the libraries also. So when you would have downloaded Microsoft Visual Studio, it would have come with this library also. This also library would have also downloaded. So if you download it on Linux, the pthread library would have downloaded. Right?
Library or only the file? Okay, yeah, library. Right.
The whole library, file, DLL, CPP, everything. All the source file, include files, everything. Whatever you need to create those threads. I think that is everyone should
Amit,
understood this by now, right? Hello?
like when you are doing just like a super basic question now. When
Tell
you
me.
are doing a hash, can you hear me?
Yeah, tell me.
Okay. So when you did a hash include thread or when you did a hash include IO string, I know that these are header files, but they also have definitions, right?
Correct.
And these
So
definitions, They are part
So
of core, what we call as core C++ library.
Yeah.
So, but
Correct.
these
Correct.
definitions are being provided, are a part of the compiler suite when you install a particular, like when you install Visual Studio. So these are definitions part of compiler suite, is it?
Yes, sir. It comes with the compiler when you download it. Okay, but think of it, these things has to be there to create the threads and all. Otherwise, if this library is not there, you won't be able to create it, because this will not be there. Has include thread. It will not be there if you have not downloaded it, right? And if you take if suppose this particular file, suppose this if I go to definition, and suppose I locate this in File Explorer. Where is this located? So this is located somewhere here, like Microsoft
Yeah,
Visual
I saw
Studio.
that. Yeah. Yeah.
Right. If I take this particular file and suppose I put it on Linux, it won't work, right? Because inside this, I must have been using system calls of Windows, and there will be no such calls, right? So it won't work. Correct. So quickly, I'll just tell you how to create the thread. So what you have to do is you have to include thread, and then how do you create thread? Is you just create the object of the thread class. So you say thread, suppose T1, and what does it take? The first argument will be from where this particular thread will be starting, the start function. Suppose the similar way we have a main thread that starts from this function. No, you have to give a starting function for this particular thread. So suppose I have some function, let's say void start function. Let's say something start func I have given, and let's say inside I am doing nothing. I'm just printing from thread func, right? Okay, and then I can give this start func, right? So what it will do is the moment it sees this code, it will generate a separate thread and it will have a separate execution line now, right? So suppose one thread that main was executing, it first came to see out, it sees this thread T1. Again, a separate line of execution will start, which will start from where? Start function, and it will go to see out, but the main thread which it has already done, it will come here. So suppose if I have separate see out statement again. So let's say print from main thread, right? So the moment this function has been executed by main thread, it will come down while other thread have gone here. There now has been, think of it as two people now running this code. One has started running from start function, and the other is going on with this main function also. Can you visualize this? One who is totally new to the multi-threading. I'm sure many are not new, they will understand, but who are new, just visualize now after this line, there are two people now running the code. One is the main thread that will go like this, and then other person who will start from here, this particular start function, and will execute parallelly. Now, how parallel it depends on the number of cores and all, but at least for visualization, think that two people are now running the code parallelly. Right? So suppose now if I want to run this, clear this and I'll build this again. What should be printed? Any idea?
That depends, no? Like we can either see both at least one print we will see from main thread, but the other one depends whether it runs or by the time program completes.
Okay. So if I run this, it is saying abort. Maybe because of that. So see, right now it has printed both the thread, both the print function, print from main thread and printing from thread func, right?
Right.
Right. What Mithun is saying is, if somebody has not understand, is like suppose main thread has started a thread of execution, right? So that thread has started from here, but the main thread has reached here, right? So as a user of the who is writing the code, he can never know which code will be printed first or which code will be printed later. As when you are writing the multi-threading code, no, that thing you have to keep in mind. You should not make a guess about, okay, this should be the first line that gets printed and this should be the second line that gets printed. That can never happen. That OS will decide according to their algorithm. That OS decides. Yeah.
If I were to add on line number 14, something like P1 dot join or some join
Yeah.
statement, then it
Yeah.
will ensure that.
Yes. So I was going to say that. So suppose now what you want is until unless this thread has done its execution, this thread has done its work, I want my main thread to just stop. Don't finish until my other thread has finished. So what you can use is you can use join for that. So once the main thread sees this line, the main thread will stop here at this particular. It won't go forward after this. And so what will happen is after this start function, the other thread has done its job. It will come here, and then the main thread will go ahead and print and then go out, right? So if I run and build this, see this is done properly. So printing from main thread and then print from thread func and then printing from main thread. Why print from main thread is afterwards? Because main thread has stopped here. Until this is finished, it is not going forward, the main thread, right? So this is how
What's
you
the
create
purpose
the
of
thread.
what is the purpose of multi-threading? Like, what problem are we solving by creating
Yeah, so
multiple threads
suppose
and use cases?
so suppose you have two functionalities that you want to do. Suppose you have one function that you want to do is you want to read a file read a file and print all the whatever it is there on the console, print everything on the console. Suppose this is one task, right? And then one second task is let's say suppose you have to print you have to print, let's say call it odd numbers on console. Now if I ask you to write the program, don't think about multi-threading for now. So how will you do it? You will write a code to read a file, and then you will read the file, you will print everything, and then what you will do is you again, after you are done with that, you will go and print all the odd numbers. Like say suppose you have to print odd numbers from 1 to, let's say, 1 to 1000. This is the way you will do.
Yeah.
If you don't know multi-threading, right? So you are reading a file, outputting everything, and then you are printing odd numbers, right? So you are taking this much time for file and then again time for odd number wala thing, right? And you know ki reading a file, writing a file takes a lot of time, right? But there is no common thing, right? Ki this has to be done first or this has to be done first. I have not told you ki you have to read a file first. Once that is done, only then you have to go and print odd numbers, right? So if I tell you to do these two things parallelly and like complete these two tasks as fast as you can, how will you do it? So what you will do is
Okay.
you will create one thread and you will tell that thread to do this task, right? And then you might create another thread and tell the other thread to do this task, right?
Right.
So what will happen is this printing file and printing also is getting done, and this printing odd number is also getting done parallelly, not one after the other. So can you visualize that it will become faster? Your whole code will become faster,
Yeah.
right?
So in the join function, we are waiting for thread 1 to complete execution, and then it will be joined with the main thread. That's what is
Correct.
happening, right? So
Yes.
I mean, in order to not jumble the operations, we have to use join, right?
Yeah.
So like in
You
this
have to
example
use
that you
join
gave,
so that the other function which was created by suppose main thread should complete the function, and then I am waiting for that thread to come and wait. So suppose if I don't give join, what will happen? Till the time, suppose there is some big thing that is going on. Suppose you are printing but suppose the same thing. Suppose you are reading a file and trying to print on console, suppose, and it will take some time. Meanwhile, what will happen is this main thread will go ahead, print it, and the program execution is done. The whole process is done only. So your this particular task is not even get completed, and then your program is done, right? So to make ensure that your this particular task is done, what you will tell main thread, hey, stop until that particular thread is done their task. You will tell it to join. Like at this particular point, the main thread will stop, and it will keep
yeah,
waiting for that particular thread to stop do away with their work and then come here, and then again it will move ahead from here. Wherever you will give the join.
Relating this with the example that you gave, reading a file and printing only odd numbers. So it has to first read in order to print, right?
No, so suppose
read.
what example I gave was I am creating two threads from main thread. So main thread is a different thread, suppose here. Suppose there is a main thread, and there are from main thread I have created two threads. Right? So one thread is doing this, one thread is doing this. So what I will do is, so suppose T1 is one thread, so I will do T1 dot join, and again I have to again do a T2 dot join also. Two things. So main thread will wait for this also and this
so
also.
Join is used only in main function.
Join you
It's
can
not
use
used
in
like anywhere else in the program.
Yeah, see, mostly it is used in main, so that main doesn't go ahead and do its work,
Okay,
and it waits for the other thread to join once they have done the work, right?
got it. Okay.
Right, but we'll get into a lot of details. I am just making it very simple to help you visualize what two threads or how the multi-threading is helpful in a process, like how to make things faster. But we'll get into a lot of details tomorrow. So I'm just stopping the class for today. And if you have any doubts for today's class, we can have 5 minutes or 10 minutes of discussion. Otherwise, we'll wrap this up, right? But tomorrow we'll do a lot of multi-threading discussions.
Just one follow-up question on this one.
Yeah.
Quick one. Actually,
Yeah.
let's say that this start func, so the thread that you have created, or the new thread that you T1, right? So T1 is reading a very large file from some network.
Okay.
And I forgot to add T1.join in the main thread. For some reason, I have not added it.
Okay.
Now the main thread will go ahead and finish. So what happens to this T1 thread? Will it keep running, or
No,
is
that
it
will
something
be,
like?
see, the thing is, when the main thread gets finished, the process is completed and process will be closed by the OS. And once
Got
process
it.
is
Okay.
called, every thing that is resource has been
All the
allocated
threads
will be
inside the
cleared up.
processor. Oh,
that is done, killed.
Yeah, there is nothing like a zombie or an orphan
Yeah,
process
correct.
that happens in the thread, because
Correct. That is for the process. Process you can make a zombie and all. Correct?
Thanks.
Yeah. So shall we wrap this up? I am giving you two homeworks. I'll give. Please, everyone, at least try it. And it is based on simple STL only. But you will have to use it. Which STL, which containers to use, which is the better container to use here, and which algorithms. That I think will open up a lot of your. It will refresh a lot of things what you have already studied in STL. So please try to do this too, and it will be a good, interesting problem I have given. So two problems I am giving, and please try to do this. If you have any confusion, ask it in Discord itself. I'll be available there. Okay, so I'm wrapping this up for today. We'll meet tomorrow at 2 p.m. sharp, same time. Okay. We'll end. Bye. Bye everyone.
bye.
Bye.
Bye guys.
Bye.
Bye.
Bye, Amit. Bye.
It's nice one.